This video will discuss ways that we can limit those confounding variables. So there's a variety of different ways we can limit confounding variables from individual differences. And the first one we've discussed, that is random assignment. You did a little activity on it even. Remember those cards where you took a coin, you decided which card was going to go into which group. Now, that's using some sort of random process to assign participants to a group, whether it's your control or experimental group. Now, you might have noticed that even though it was random, you still didn't get a perfectly even distribution. Or maybe sometimes your sample size was off. Maybe you had too many black cards or red cards or whatnot. So something we kind of glossed over is there is this idea of restricted random assignment. And there's different ways you can restrict this random assignment, but maybe you want to make sure that you have an equal number in each of your groups. So you restrict, even though you're flipping your coin and you get heads, you have 50 individuals in your group, it's only the first 25 that end up in 25 heads that end up in that control group, and the rest will end up going into that experimental group. You could have stratified randomization where you want to work on the proportion of some sort of extraneous variable and control for that. So you're restricting your random assignment in some way, so it's not just simple random assignment. Now, another thing we can do is matching groups. It's sometimes called matched assignment. So this is where you match individuals in the group on some sort of variable. So you identify a variable that you are worried could become a confounding variable, and you have to measure it, and then you have to match individuals that have similar levels of whatever that variable is. So first you identify the variable to be matched across groups. Then you measure the matching variable for each participant. And then you use restricted random assignment to assign the participants to groups. And now for an example. Here are my 10 participants, and it's only 10 participants just for the ease of demonstration. So the first thing I have to do is decide, is there a variable that I think could become a confounding variable? And if so, I have to measure that. So here I've chosen IQ, and I've gone ahead and measured it, or I've had those measurements from some previous study or school event or something like that. And then I have to match these individuals. So here I've matched Amy and Liam. They both have an IQ of 100. I've matched Todd and Leanne. They both have an IQ of 95. Cruz and Zoe at 120. Smarty's pants there. Esmeralda and Miguel at 115. And Camille and Santiago at 90. And then I'm going to use some sort of randomization technique. So I have 5 groups. I'm going to assign the first individual in each group randomly. So tails, they're going to go in one group, heads are going to go in another. So I've done that. And then, so if Amy goes in condition 1, Liam then goes in condition 2. So, and then heads would be Todd going in condition 2, and then Leanne would go in condition 1. So group 1, Amy, Leanne, Cruz, Esmeralda, and Santiago, based on my coin toss. And then their partners go in the opposite group. And that is how you match assignments. Another thing you can do is hold a variable constant. So let's say you think that one of the variables might influence your study, and you don't want to do the matching because that can be tedious, it can be time consuming, it could be expensive. So the idea is that maybe you then just limit your group to something. So perhaps gender, then you only measure one gender. So you eliminate that as a potential variable. If it was IQ, maybe you only use people above an IQ of 100 or something like that. So here's an example. Let's say the experimenter decides that gender may be a confounding variable. So we have a population of males and females, but we select only females. So our sample becomes only females, and we put those in our control and experimental group. And actually I had a group last semester on their experiment that they decided that they really only wanted to use females. They thought that gender could be an influencing factor. And we originally were going to have experiments that had 2 independent variables, and they were going to use male and female as kind of a quasi-experimental independent variable, which we'll talk about later. And so they decided they only wanted to have females in their study.